Good day, everyone. My topic is all about integrating a discontinuous integrand. So now let's examine in what is integrating a discontinuous integrand. Integrals of a function containing an infinite discontinuity in the interval over which the integration occurs. Consider an integral of the form integration from a to b f of x dx, where is continuous over a and b and discontinuous at b. Since the function f of x is continuous over a and d for all values of satisfying a less than to t less than b, the integration from a to b f of x dx is defined for all such value of t. Thus, it makes sense to consider the values of integration a from a to t f of x dx as t approaches b for a less than t less than b. That is, we define the integration from a to b f of x dx is equal limits of t which approaches to b to the power of negative or left integration from a to t f of x dx, provided this limit exists. So here's the definition. The definition of converging and diverging improper integral. First, let of x be continuous over a and b, then the integration from a to b f of x dx is equal limit of t which approaches to b negative, the integration from a to t f of x dx. Number 2, let f of x be continuous over a and b, then the integration from a to b f of x dx is equal limit of t which approaches at a to the power of positive, the integration from t to b f of x dx. In each case, if the limit exists, then the improper integral is said to converge. So we need to remember that all the time or always. And if the limit does not exist, then the improper integral is said to diverge. Then number 3, if fx is continuous over a and b except at a point c in a b, then the integration from a to b f of x dx is equal integration from a to c f of x dx plus integration from c to b f of x dx. Provide both integration from a to c f of x dx and integration from c to b f of x dx converge. If either of these integrals diverges, then the integration from a to b f of x is diverges. So let's try an example. So here's the example. Example number 1. Evaluate in the integration from 0 to 4 1 over the square root of 4 minus x dx if possible. State whether the integral converges or diverges. So here's the solution. If the function f of x 1 over the square root of 4 minus x is continuous over 0 and 4 and discontinuous at 4, using equation number 1, which is the integration from a to b f of x dx is equal limit of t which approaches to b to the power of negative, the integration of a to b f of x dx is equal to limit t of which approaches to be negative to the power of negative integration of t from a to t fx dx. So, the example number 2, evaluate the integration from 0 to 1, 1 over x dx. If possible, state whether the integral converges or diverges. Solution. If the function f of x is equal 1 over x is continuous over 0 and 1 and discontinuous at 0, using equation number 2, which is integration from a to b, f of x dx is equal limits of t which approaches at 8 to the power of positive integration from t to b, f of x dx. So first we need to write as a limits. The integration from 0 to 1, 1 over x dx is equal limit of t which approaches at 0 to the power of positive. The integration from t to 1, 1 over x dx. So, next, find the antiderivative. Limit of t which approaches at 0 to the power of positive ln absolute value of x evaluated from t to 1. Third, evaluate the antiderivative. Limit of t which approaches at 0 to the power of positive ln absolute value of 1 minus ln absolute value of t is equal limit of t which approaches at 0 to the power of positive ln absolute value of 1 minus ln absolute value of 0 equal limit of t which approaches at 0 to the power of positive negative ln 0. Then evaluate the limit. Negative times negative a infinite. The final answer is infinite. So we conclude that the improper integrals is diverges, or the improper integral is diverge. That's all. Thank you.